Good morning, everyone. Today I'm here to present our topic predicting house price linear regression versus decision trees. I'm going to talk about two machine learning models, linear regressions and decision tree regressions, and how they are used to predict house price. Accurate house price prediction is important for buyers, sellers, banks, and real estate investors. It helps in making smart financial decisions, saving money, and reducing risk. I used the Boston housing dataset. It contains information about different house and neighborhood, like how many rooms a house has, the crime rate, and the percentage of low income people. Our goal is to predict the median value of a house in $1,000, which is given a column or a mid feet. And the next is data processing steps. To prepare the data, I loaded it using pandas and check for any missing values. There were none. I separated the data into features called X and the target Y equals house price. Then I split the data into training and test sets using 70 to 30 ratios. I also used a standard scalar to scale the features. These steps is important for linear regressions. Next is model implementations or building the model. I built two models. First, a linear regression models. It assumes a straight line relationship between input and output. It is very easy to understand and interpret. And second is decision trees. This model can handle complex nonlinear data. I limited the depth of the tree to 5 to avoid overfitting. I used squared error to evaluate splits in the trees. And the next is comparison the Z. I used three matrices to compare both the models MSC, MAE, R squared. So MSC means mean squared error, MAE mean absolute error, R squared score. Explain how well the model fits the data. Here are the results. Linear regression MSC 24.32, MAE 3.1, R squared 0.7. And the conclusion and justification to summarize, decision trees are better when the relationship between the data is non-linear. Linear regression is simpler and easier to explain. So if we want accuracy, decision tree is better. But if we need explainability, like in banking or healthcare, linear regression is a better choice. And the next is future improvement. In the futures, we can tune the decision tree using grid search CV. Try getting a new features like combinations of variable. Use explainability tools like Sharp to understand how the tree makes decision.
Afternoon everyone, myself Mohammad Shoaib. I am going to explain this code. In this code we are going to import Python libraries such as pandas and numpys for handling data, matplotlib.pyplot and seaborn for plotting graph. and sklearn modules for building model and evaluating and data processing. In the second step, we are going to load data. In this, we are going to insert data train underscore df as input features for the target, and test df for generating final predictions. In step 3, we are going to process the pre-processing for removing id, whereas id column is just a unique identifier. It doesn't help in prediction. We just save test ids so we can use them later in the submission file. In the next step, we are going to use separate features and targets, where we are going to assign y value is equal to what we want as a predict for sale price, and x as the input features. In the next, the combine train and test. It is used because of combining both datasets helps applying consistent pre-processing like filling missing values and encoding categories. In the next, we are going to see handling missing values, where we are going to fill the missing values in the numeric values using the median such for each value, such as numeric and median. In the next, we are going to use encode categorical variable. It is used because machine learning modules need numeric inputs, not text. Label encoding turns text categories into numbers such as x is equal to 0 and jd is equal to 1. It is just an example. In the next, we are going to use split combined data, where we split the pre-processed data back as x is equals to processed training data, and x test final is equal to processed test data for the final prediction. In the next, we are going to see the splits into train and validation. It is the purpose we use to divide the training data. 80% of the training data is in the X train and Y train. In the 20% of the validation or testing is done by X valuation and Y valuation. This helps evaluating model performance before using test data. In the next, we are going to see train linear regression model. For example, for explanation, create and train a linear regression model, then making it predictions on the validation data. In the next, we're going to see train discussion tree model, where we are going to build a discussion tree model good for the nonlinear pattern, predict house prices on validation sets. In the next, we are going to see evaluate models. We are going to print this. It will show such as r square score, which is equal to which gives the value how well the model explains the variance. 1.0 is equal to perfect, for example, or MSC the measures the value of average squared error, where lower is equal to better. In the next, we are going to see the visualize predictions, such as plotting actual prices versus predicted prices. A good model will have the points close to the straight and diagonal lines. And predicting the test data, what does it do? It means that uses the trained linear regression model to predict prices for unseen test data, such as Kaggle test file. In the next, we are going to create a submission file. It is a purpose for creating a CSV file with ID from the original test data, sale price for predicting our model. Thank you. And this is what the output we have got. As we have considered the linear regression, the R2 score is given as 0.844, and the MSC score has been performed as 1194210039.6. For in the variable for the variable as the discussion tree prediction, the R2 score is 0.73, and the MSC score is given below 201849294.4. And this is the output we have got for plotting the actual graph. Thank you.